Hello, welcome back to lesson 5.3. We are going to learn about the binomial distribution. And in the word binomial is the word prefix bi, which means two. And so we are going to learn about distributions where there's two outcomes. In this lesson, we're going to learn how to prove a binomial experiment, how to calculate a binomial probability, and how to calculate the mean and standard deviation of a binomial distribution. So a binomial experiment has four characteristics. The four characteristics are there is a fixed number of trials, meaning I'm going to roll the die 5 times, not I'm going to roll the die until I get a 6. It's a fixed number of trials. We denote that with an n, little n for sample size. Number 2, there are only two possible outcomes, either a success or a failure. The probability of success and failure always equals 1. We usually define the probability of success with a P here, and the success of a failure with a Q. Number 3, we define X as the number of successes. X can be between 0 and N inclusive. And the fourth characteristic is the N trials are independent and are repeated using identical conditions. Because the N trials are independent, the outcome of one trial does not help in predicting the outcome of another trial. Another way of saying this is that for each individual trial, the probability P of a success and a probability Q of a failure remain the same. So for example, randomly guessing a true-false statistics question has only two outcomes. If a success is guessing correctly, then a failure is guessing incorrectly. Suppose Joe always guesses correctly on any statistics true-false question with probability 0.6 and probability of failure of 0.4. This means that for every true-false statistics question, Joe answers his probability of success as P equals 0.6 and Q equals 0.4, and they remain the same. The outcomes of a binomial experiment fit a binomial probability distribution, where X is the number of successes obtained in the N independent trials. The mean of a binomial probability distribution is shown as mu, and that equals N multiplied by P, the probability of success. The standard deviation is sigma, and that equals the square root of N times P times Q. And we have a Bernoulli trial. A Bernoulli trial is an experiment, has the same characteristics 2 and 3, where N equals 1. So your sample size is only 1. That's a Bernoulli trial. So let's dive into these binomial experiments. At ABC College, the withdrawal rate for an elementary physics course is 30% for any given term. What would we define as success? So success would be anyone who withdraws from the course. Even though we would usually consider withdrawing from a course as a negative, it's still considered the success in this case because that's what we're counting. What would we define a failure? A student who does not withdraw. What is the probability of a failure? So if P is 0.3, then Q is equal to 1 minus P, or 1 minus 0.3, or 0.7. Example 2. It says the state health board is concerned about the amount of fruit available in school lunches. 48% of schools in the state offer fruit in their lunches every day. So why don't you pause it and answer these questions and see if you agree with my answers. Okay, what would we define a success as? A success would be a school that offers fruit. What will we define a failure as? A school that does not offer fruit. And what is the probability of failure? So the probability of success is the probability that they offer fruit. So P is equal to 0.48. So Q is equal to 1 minus 0.48 or 0.52. Sometimes we're given a situation and we need to decide if an experiment is truly a binomial experiment. So for the two situations below, decide if they are a true binomial experiment by going through the four characteristics. And if they are, then define X, N, P, and Q. So it says 65% of people pass the state driver's exam on the first try. A group of 50 individuals who have taken the driver's exam is randomly selected. Give two reasons why this is a binomial problem. So one, we have a fixed number of trials, meaning the 50 individuals that took the exam. Two would be probability of success is 0.65. That means the probability of failure is 0.35, and trials are independent. And X is going to be anywhere between 0 and 50. Let's look at B. It says a lacrosse team is selecting a captain. The names of all the seniors are put into a hat, and the first three that are drawn will be the captains. The names are not replaced once they are drawn. One person cannot be two captains. You want to see if the captains all play the same position. State whether this is a binomial or not, and state why. So the first three that are drawn, so my fixed number of trials is 3. I'm drawing 3. Okay. Probability of success is changing because once you draw, they're not being replaced. So they're not independent of one another. So this is not a binomial. The notation for binomial is usually X is, and you use the tilde symbol, B for the binomial, where N is the number in your sample size that you're running the trials, and P is the probability of success. And we're going to use this in Desmos in our calculations. So let's look at example 4. It says, it has been stated that about 41% of adult workers have a high school diploma, but do not pursue any further education. Let X be the number of workers who have a high school diploma, but do not pursue any further education. Okay, so X takes on the values of 0 to 10. There are 10 of them that they ask the question. Probability of success is 0.41, and so the probability of failure is 0.59. And so this is how we describe the distribution. And it says if 10 adult workers are randomly selected, find the probability that exactly 6 of them have a high school diploma but do not pursue any further education. So we need to find the probability that X equals 6. Okay. Go ahead and go to our Desmos screen here so you can see that what we are going to type is binomial dist. And you can just save, if you click on this in Canvas, you can just save this as stats less than 5.3. So you've got all of the commands right here. So this right here is 10 and 0.41. and exactly 6. So now it's really cool. In Desmos, you can say, I want the inner, the outer, the left, or the right. And actually, if you just turn off the cumulative, I'm going to turn on the graph right here and turn off these other graphs. So I turned on the graph so I can go over here and look at exactly 4 and just, I'm sorry, exactly 6. We wanted to know exactly 6. So that is 0.1209 when you round appropriately. 1209. So this x-axis is the number of workers, and then the probabilities are there. And if you look at B, it says, what is the number of adult workers that you expect to have a high school diploma but not pursue any further education is the mean. So let's go back to our course pack here. So the mean is calculated as N times P. There's 10 workers and a 40% likelihood that they did not pursue any further education. So that is likely to be 4.1 workers on average. And the variance is the N times P times Q, and the standard deviation is the square root of that. So if we take the square root of N times P times Q, we get 1.56 workers. Table 5 says, about 32% of students participate in a community program outside of school. If 30 students are selected at random, find the following. So if you turned to the end of chapter 5.3 here on page 119, you will see the words that are going to be described in some of the problems, the symbols that will be used with those words, the commands that you would use in ALEX if you wanted to do them. So some of them are NCX, so like the choosing, remember we did the combinations and permutations. And then this B sub NP is that binomial distribution. Or you can use the Desmos command that we just used. And so this is how we would use them. So let's look here, example 5. The probability that exactly 9 of them participate in a community volunteer program outside of school. So exactly 9. So the probability of X equals 9. Is, we've got N equal to 30 and P is equal to 0.32. So there's a couple ways we could do this. We could either do 30 choosing 9 times P to the X, which is 9, times 1 minus P to the N minus X. So that's one way. Or we could use the binomial distribution. And if you use the binomial distribution, I'm going to share the screen again. And you can see here, example 5, binomial distribution is 0.32. And if we want to look at exactly 9, I'm going to turn off this graph and turn on this graph. And we can go over to 9 and click on that. And it will match what you get in ALEX. And if we round to 4 decimal places, it's 0.1530. And then part B says the probability at most 14. So at most 14 means I can include 14, but it's going to be everything below that. So if we go back to our course pack, this is how we would write that on our paper. Probability of X less than or equal to 14. We can include 14, but it's everything below that. And so you can either use your Alex command. So at most would be right here. So you could either use the Alex command, or you can use the binomial dist in Desmos and then choose left and use N. And so let's go to Desmos and do that. So I'm going to go back to my Desmos screen so you can see. So right here, I'm going to turn this off. I'm turning this one on because I'm going to choose left because I want everything less than, and I want everything less than 14 because I want to include 14. And you'll see that we're including 14 because all the ones we're including have a solid circle here. We're not including 15, 16, and beyond. And so that probability is right here at 0.97. 4 decimal places would be 0.9695. 0.9695. So number 6 says, in 2013, Jerry's Artorama art supplies catalog, there are 560 pages. 8 of the pages feature signature artists. Suppose we randomly sample 8 pages. Let X be the number of pages that feature signature artists. What values could there be? So we are, there are possibly 8 pages that could take on this. So between and so what is the probability distribution? It is binomial, and we are sampling 8 pages, and the probability is there are possibly 8 out of the 560 is a success. 8 of the pages feature signature artists, and we randomly sample 8. So it could be the 8 that we sampled are the 8 that feature the signature artist. However, there's 560 to choose from, so that are possible. Okay, they're probably that 2 of the pages feature the signature artist. Our probability of X equals 2. And so we are practicing how we're going to type it in Alex. So that means we have 8 choosing 2. And then the probability of success is 8 out of 560 to the 2 times 1 minus 8 out of 560 to the 8 minus 2. And we can always put that into Desmos. And I'm going to show you the screen here. So here we have our distribution. and it's very small. The likelihood of, let's see, the likelihood of two of them is, the likelihood of one is the highest you can get, and that's about 10%. But the likelihood of two of them, the 8 pages, being two that actually have a featured artist is 0.0052. And then 2 says the probability that at most 6 pages feature signature artists would be less than or equal to 6. And so in Desmos on that, I'm going to show you the screen here. So in Desmos, we're then going to choose a less than, it's going to be the less than or equal to 6, which is almost everybody. So it says 1, but it's really 0.99999. It's pretty large because it's including almost everyone. 3 says, what is the probability that more than 3 feature signature artists? So this time we're going to do a right. We're going to do greater than or equal to, we don't want to include 3 because it says greater than 3. So we want to say greater than or equal to 4. And that number is super small. Here it is in decimal form. 0.001278. Extremely small. And then if we want to find out the mean, so out of drawing 8 pages, on average, we would expect to get 0.1 page. So it's not very likely that, because there's 560 pages in the book, only 8 of them are even possibly featuring a signature artist. So it's tricky. And then we have a standard deviation of 0.3356. So touch me back for a separate video on 7 and 8 if you need the extra help. You don't have to watch it.